Hey, it's Miss Matt here. I'm going to be going over lesson 14 since I'm not in class today. Um, the nice thing about having a video of me going over a lesson is anything that you didn't catch the first time, you can just back it up and look at it again. So we're going to be actually solving some equations using logarithms today. And you've done a little bit of that so far, but there's a lot more to learn about. So that's what's happening here. So this is your warm-up. It's on page 238 in your textbook. And I'll just be kind of going through it with you, using the calculator, talking about the calculator keys that you need to use and whatnot. So here we go. So we have this equation right here. Lynn is solving this equation. 5 times e to the 3a is equal to 90. And so the variable we're trying to solve for is in the exponent. And so that's when you use a logarithm to figure out a variable and an exponent. And so we're looking at the steps that Lynn took to do that. So I'm just looking at the first 2 steps. So here's the equation written out. And I notice from this step to this step, the 5 is gone, and the 90 is now an 18. So I believe what happened in that step is dividing both sides of the equation by that 5. And if you check on your calculator, you'll see, oh yeah, 90 divided by 5 is 18. So to go from this step to this step, dividing by 5. And our overall goal is to determine if the solution is valid. So far, so good, because she correctly divided both sides of the equation by 5. Next, 3a is equal to log base e of 18. So it looks like the base in the exponent part of the equation was e, and then she correctly made that the base of the logarithm. So far that looks great. And then I noticed that the exponent 3a, that's the answer, and then this is the logarithmic expression with the 18 in the correct place. So this step was just switching forms. And she correctly switched forms. All right. And now I see the last step is the a is, this was a 3a and now it's just a. And so you get that by just dividing by 3. And she divided over here by 3 as well. So to get to that last step, she just divided by 3. So it looks to me like all of this was done correctly. So first she isolated the exponential part of the equation by dividing by 5. Then she switched forms and then continued to solve for a by dividing by the 3. So yes, I totally think her solution is valid, and that's why. All right. So we haven't seen a log with a base e before. So log base e of 18 divided by 3. So this would be the exact solution for a. And you might notice when you look at the table on the next page, something looks a little bit different. So we haven't seen this before, but what you might notice in this table is here we have an exponential form where e is the base of the exponent, and then it looks a little different over here in logarithmic form. So there's something that you need to know. You don't know this yet, that the log base e of some value can be written as the natural log of that value. So just like log without a base, so like maybe log of 100, this has an automatic base of 10. This is how you write base E. And you'll notice that the button we were using on the calculator the last couple days is the log button for the base of E. So when your log has a base of E, this is the button that you use on the calculator. All right. So when I look at this in exponential form, I notice the base is E, and so we have the natural log. So e to the 0 is equal to 1. So then the natural log of 1 is equal to 0. Again, the natural log is the log where the base is e. Okay? So for part B, problem B here, if e to the first is equal to e, then the natural log of e is equal to 1. All right? If e to the negative 1 is equal to 1 over e, then log base e, right, or the natural log of 1 over e is equal to negative 1. All right, so going backwards, I notice this next question has a natural log in the log form. So that tells me the base is e. The base is e. The exponent is negative 2. And e to the negative 2 is equal to 1 over e squared. All right, and then finally going from e to the x is equal to 10, in logarithmic form, log base e of 10 is equal to x. So I'm going to write that over here. Log base e of 10 is equal to x. So this is what you're more familiar with. But again, when you see those two together, we're going to write it as the natural log of 10 is equal to x. Okay, so being able to convert between exponential form and logarithmic form using base e and the natural log. That's the big idea for this part of the lesson. Now we're going to put that to use in solving for some unknown values in some simple equations. All right? So it says solve each equation by expressing the solution using ln or natural log notation. Then find the approximate value of the solution using the ln button or natural log button on a calculator. All right, so I'm going to first write this in solving for m and representing the solution using natural log. I think I'm going to do the in-between step too, just because it's new for us. So I'm going to have a step that looks like this before I get to that. Once you're feeling comfortable with the material, you don't have to put that step in there. All right. So again, I know the base is e, right? So it's going to be the base of the log as well. So m is equal to log base e of 20. Okay, log base e we can write as the natural log of 20. Okay, these are equal to each other. So my estimate, knowing that e is equal to about 2.718 and thinking of it as, I'm thinking of it in like powers of 3, because like 2.78 is close to 3, or 718. 2.718 is close to 3. So I'm thinking of it as powers of 3. I know 3 to the second is 9, and 3 to the third is 27. So I'm thinking it's going to be between 2 and 3 somewhere. So I can find a pretty good estimate on the calculator by just typing in the natural log So the LN button, let me zoom out a little bit so you can see more of my calculator. So right here, the natural log button, the natural log of 20, oh, really close to 3, 2.995732274, and so on. So the natural log of 20, I'm going to round that to 2.996. 2.996. All right. So for each of these, you would do that in the same way. You might want to like pause the video and do them on your own and then check your work. So pause for a second, come back and check your work. All right. So I'm going to go over these last two. So you should have m is equal to log base e of 30, or the natural log of 30. And on the last one, p is equal to log base e of 7.5, or the natural log of 7.5. And get the calculator. So the natural log of 30 and the natural log of 7.5. All right, so there they are, 3.401 and 2.015. Oh, I forgot to estimate. Oops. Got ahead of myself there. All right, so simple equations. We're going to do a little more work with equations where we have are solving for an unknown exponent, and we're going to use only base 10 or base e. And so what's nice about that is that those are the two bases your calculator knows. So remember, our log button is automatically in base 10, and our natural log button is automatically base e. And it kind of reminds you, like that little blue writing above, see how you kind of go, oh, there's a 10 above the log button. That's because this log button is in base 10. And then there's an E above the natural log button. That's because the natural log is base E. So it's kind of nice how that goes together on the calculator buttons. All right, I'm going to try and get through this next one. I know these seems like a lot of equations here, but some of them are not that difficult to solve. And then they just kind of get a little more difficult as we go down the list. So let's see here. Without using a calculator, solve each equation. Well, I'm going to change that a little bit, is that if we have a value that's not the exact value, like not a power of the base, then I'm going to have you eventually use a calculator and get an estimate approximation, but it has to be in log form first. Okay, so when we're solving an exponential equation, you want the x, like the base and exponent, to be the only thing on that side of the equation before you switch to log form. So on number 1, we're supposed to use a logarithm. Oh, it says some will be expressed using log notation. I kind of want to make them all go into log notation and then also give the answer. So for number 1, 10 to the x is equal to 10,000. X is equal to the log base 10, which I don't need to write the base, of 10,000, which I know is 1, 2, 3, 4, 4. Okay, that was not too bad. On number 2, I noticed that 10 to the x is not the only value over here, so we have to start by dividing by the 5. So that gives us 10 to the x is equal to 100. So x is then the log base 10, or just log, of 100, which is 2. Again, if I'm going too fast, it's just because I'm trying to get the video done. But you can always pause, rewind anything you missed, and come back. All right, so I'm going to keep on going. All right, On number 3, well, this is interesting. We have x plus 3 in the exponent. So that whole expression, x plus 3, that whole thing is the exponent. So I'm going to switch this to log form and say x plus 3 is equal to the log base 10 of 10,000. Okay, now I know this is 4, right? We found it for number 1. So that means x plus 3 is equal to 4. Subtract the 3, x is equal to 1. All right, number 4. 10 to the 2x is equal to 10,000. So again, I'm going to switch to log form. 2x, the exponent, right? Because 2 times x is the whole thing for the exponent, is equal to log base 10 of 10,000, or just the log of 10,000. The log of 10,000 is 4. I feel like a broken record. So this is equal to 4. If 2x is equal to 4, then we divide by the 2 to get x. So dividing by the 2, x is equal to 2. I should really be boxing these answers, huh? I'll do that. Okay. Number 5. 10 to the x is equal to 315. Well, 315 is not a power of 10, but I'm going to go ahead and write this in in logarithmic form. So the exponent is equal to log base 10, which is just log of 315. So that's the exact answer in logarithmic form. And then the decimal approximation, the log of 315 is about 2.498. All right. For the next one, 2 times 10 to the x is equal to 800. Again, 10 to the x is the exponential part of the equation. It needs to be isolated. We do that by dividing by the 2. Okay, so when we divide by the 2, we get 10 to the x is equal to 400. 10 to the x is equal to 400. 400 is not a power of 10, so I'm going to write the answer in logarithmic form. X is equal to log base 10, or just the log of 400. And using the calculator, the log of 400 is approximately 2.602. So this is about 2.602. All right. Wow, we're over halfway done with these. There's a lot of problems on this page. They're quick though. Okay. Now we have like more of an expression in the exponent up here. So again, 4,000 is not a power of 10. So I'm going to go ahead and write this in logarithmic form. So 1.2x is equal to the log of 4,000. All right. Now, since that entire expression was the value of the exponent, now I'm just going to divide by it. Divide by 1.2. Do it on both sides. That gives us x by itself, and this is a value we can put into the calculator. When you put this into the calculator, you have to be really careful, because if you forget to do something, you will get the wrong answer. So I'll show you what I mean. So the log of 4,000, see how this opens a parenthesis? you want to close that parenthesis before you divide by 1.2. Okay, so that would be the correct answer, but if I forgot to do that, oh, they're different, right? They're not the same answer. So you do have to make sure that when you use the log button, it opens the parenthesis. Make sure that you close it if you have to do any other work. So about 3.002. Round it. All right. Okay, number 7. Again, the exponential part, the base and exponent need to be the only thing over here before switching to log form. So we would start by dividing both sides of the equation by 7. All right, so we then get 10 to the 0.5x is equal to 10. Well, I know that that means that 0.5x just has to equal 1, right? Because 10 to the first is how you would get it to equal 10. So I'm actually not going to write this in log form. 0.5x is equal to 1 because this is 10 to the first. So if their bases are the same, their exponents have to be equal. And so solve this by dividing. And x is equal to, this is equal to 2 when you divide. All right. Now, I hope you've noticed that the last two equations here to solve have a base of e rather than a base of 10. So we're going to follow the same steps when we convert it to log form. We're going to use the natural log rather than the log, log, rather than log base e. So here we go. Again, the base and exponent need to be isolated before anything else. So divide both sides of the equation by 2. So we have e to the x is equal to 16. So our exponent x, I'm sorry, not 16, 8. Haha. 16 divided by 2, 8. So our exponent of x is equal to the natural log of 8, right? Because our base is e, and log base e we write as the natural log. And so this is the exact value using a calculator for the natural log of 8. We get about 2.079. Now, that makes sense again because like 3 squared is 9. So I'd expect the answer to be around 2 for knowing that E is about 2.718. So this number does make sense to me. So about 2.079. And finally, number 10, we have a little bit of work to do here because, again, the base and exponent need to be isolated. So I'm going to divide both sides of the equation by 10. And so that eliminates, I never cross those out, that eliminates the 10s. And so we have e to the 3x is equal to 250 divided by 10 is 25. Okay, so we're solving for an unknown exponent. We're going to switch to log form. The base is e. And so our exponent, 3x, is equal to log base e, or natural log of 25. But this isn't x, this is 3x. So now we need to divide by that 3. And so this is what then goes in the calculator. Again, when you put in natural log, it opens a parenthesis. So the natural log of 25, close the parenthesis, and then divide by 3. And there we go, 1.073. All right, so we've just spent this time learning how to solve equations, solving for an unknown exponent using log base 10 or the natural log, log base e. So there's the final answers if you need to see any of them again and didn't want to rewind. Let's take a look at the lesson summary, and then we are going to be done with the video for today. So the lesson summary has done a really nice job of showing you two different equations, one using log base 10 and one using, actually they're both base 10, aren't they? Oh, so I'm so confused. Oh, it's using two different methods. So this is kind of like what we did on number 8, where if you know this is a power of the base, you can rewrite it using the exponent, and then you can just solve for the exponent. We did that on number 8. Or if this isn't a power of the base, you can solve using a logarithm. All right, so that's a nice example there. And then it does a good job, again, of explaining the natural log function. When the base is e, you can use the natural logarithm, the ln button on your calculator. All right, so you do have an assignment. It's numbers 1 through 6 on this page 243. And I will see you tomorrow. Have a good day.